Today we're looking at notes 5-9, factoring with complex numbers. So first I want to refresh your memory. If I ask you to simplify square root of 16, hopefully really quickly you would tell me, well, that's 4. And the square root of 49, you would tell me, well, that's 7. Okay, but if I ask you to tell me the square root of negative 81, if it were just 81, you would hopefully tell me 9. But since it's negative 81, you would tell me 9i. Okay, similarly, if I told you to find the square root of negative 9, okay, because it's a negative, that's going to be 3i. Okay, and the square root of negative 4 is going to give me 2i. So hopefully knowing that will kind of help you with what we're doing today. So also some refresher, if I'm asking you to factor, I want to review the fact that x squared minus 16 is called a difference of squares, okay, and without even really thinking about it, you should be able to quickly factor this and say that because this is a difference of squares, I'm looking at the square root of this, which is x, and the square root of this, which is 4, and you go ahead and put a plus on one and a minus on the other, and you're done. Okay, likewise here, same thing, difference of squares. Okay, because that's a difference of squares, you know the square root of 4x squared would be 2x, so 2x here and 2x here. The square root of 25 would be 5, so 5 here and here, 1 plus, 1 minus, and you're done. Okay, so also this is not quite a difference of squares yet, but let's see if it turns into one. If I factor out that GCF of 2, x squared minus 36, what do you know? It is now a difference of squares. So this would be 2, x here, 6 here, 6 here, because 36, 1 plus, 1 minus, and you're done. Okay, so similarly today, we're going to be factoring, but it's not a difference of squares, it's a sum of squares. So, and how I can use this formula per se to factor this is manipulate this to be a difference of squares. So here I can rewrite this as x squared minus negative 16. Hopefully at home you can say, oh yeah, that's the same thing. Minus a negative turns to plus. So that and that, they're the same thing. So now I have manipulated this to be a difference of perfect squares. X squared is a perfect square and negative 16 is a perfect square. Okay, so this is a difference of two perfect squares. So this, when I factor it, is going to look like x, the square root of negative 16 is 4i. So 1 plus 4i and 1 minus 4i. Likewise, I can manipulate this sum of perfect squares to be a difference of perfect squares. So 25x squared minus negative 1. Okay, where that's a perfect square, that's a perfect square. So I have in front on this one 5x, because the square root of 25x squared is 5x. 1 plus, 1 minus. The square root of negative 1 is just I. Okay, and so likewise here on this one, I don't quite have perfect squares, but maybe I will. Let's go ahead and factor out that GCF of 2, and then what do you know? Perfect squares, but I need to manipulate it. So 2x squared minus negative 9. Okay, so now I'm going to have 2, x in front, 1 plus, 1 minus. The square root of negative 9 is 3i. Okay, here I've got 49x squared plus 81, so I'm going to change that to look like 49x squared minus negative 81. So I'm going to have, when I factor 7x in the front of each binomial, 1 plus, 1 minus, the square root of negative 81 is 9i. Oops, 9. There we go. Hopefully that looks more like a 9. All right, last but not least, remember you always want to look for a GCF. So on this one, I definitely see right away 4 divides into both of these. Okay, and now I can manipulate it to look like a difference of squares. Okay, so I would have 4 x in front, x in front. The square root of negative 25 is 5i. 1 plus, 1 minus. And that sums up today's lesson.